This is part 5 of the series Parallel and Perpendicular Lines, and in the last part we worked the proof of the alternate interior angles converse theorem, and we're going to start this session off with a proof of the consecutive interior angles converse theorem. Now the setup for this proof is a little bit different than the last one. Here we have two lines cut by a transversal, and we're given angle 1 and angle 2 are supplementary. These aren't congruent now, they're supplementary. So I've gone ahead and written down my given statement, and let's see if we can come up with some scheme for how we're going to execute this proof. Well, I'm going to go back to my idea of the corresponding angles being congruent and therefore the lines are parallel. That's the standard for these proofs, because that postulate, the corresponding angles converse postulate, allows us to prove most of these other theorems. So I know that angle 1 and this angle are supplementary because they're a linear pair. So that we have something to refer to, let's go ahead and write in that this is angle 3. So this is angle 3 here. All right. Now I know that angle 1 and angle 3 are supplementary because they're a linear pair. And if angle 1 is supplementary to angle 3, and I already know that angle 1 is supplementary to angle 2, then I know that I have two angles, 2 and 3, that are supplementary to the same angle, angle 1. And if you remember the congruent supplements theorem, you know that if you have two angles that are supplementary to the same or congruent angles, then those angles have to be congruent. So the congruent supplements theorem allows me to say that these two angles are congruent. Therefore, these two lines are parallel by the corresponding angles converse postulate. So that's the general plan for my proof. Now you're not always going to be able to do it like I'm doing it here. These are relatively simple, straightforward proofs. You're going to see proofs later on that we're just going to have to go along with the flow and see where they lead us. But these are short enough and simple enough that you can get from start to finish pretty much with 2 or 3 steps. But don't think that this is going to hold. You're not going to be able to do this all the time. But you can always come up with a general plan that will lead you in a certain direction. All right. First thing we did was we said angle 1 is supplementary to angle 3 because they're a linear pair. So we've got angle 1 supplementary to angle 3. That's the linear pair postulate. Linear pairs are supplementary. Now we know that angle 1 is supplementary to angle 2, and angle 1 is supplementary to angle 3. So here we have two angles, 2 and 3, that are supplementary to the exact same angle. So that tells us that angle 2 is supplementary to angle 3. As usual, what we're doing with these proofs is we're letting the information guide us. What does this tell me? Since this is supplementary to this and this is supplementary to this, these two are supplementary to the same angle. Therefore, angle 2 is congruent to angle 3, and that's the congruent supplements theorem. Well, now that we know that angle 2 is congruent to angle 3, and since these are corresponding angles, we know by the corresponding angles converse postulate, if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines must be parallel. So now we're ready to make our final statement. Line L is parallel to line M, and the reason for getting from here to here is the corresponding angles converse postulate. And there's our proof. Now hopefully as we go through these proofs, and I'm hoping that you're trying to work them on your own, that you're starting to see these patterns that are recurring, and that's the key to learning this material. The more you do these, the easier this is going to get. All right, before we move off of parallel lines, we have one more property that we're going to look at, and it's another transitivity property. And this is going to be the parallel line transitivity property. The parallel line transitivity property says if two lines are parallel to the same line, then they are parallel to each other. So we have here in the picture, line L is parallel to line M. We also have line M is parallel to line N. We have two different colored arrowheads in here. So because this is parallel to this and this is parallel to this, this must be parallel to this. Now we could show this if we wanted to we could draw in a transversal, and by drawing a transversal, we could create some angle pairs. So if we wanted to do that, we could go ahead and do that. And we could set up some different angle measures here. If we wanted to put in, let's say, we'll call this angle 1, and then this will be angle 2, and we'll call this angle 3 and 4. All right. So we can see that this angle and this angle, because we have two parallel lines cut by a transversal, angle 1 and angle 2 are congruent. And since we know that these two angles are congruent because they're vertical angles, angle 3 is congruent to angle 1. And since we know these two angles are corresponding, then we know that these two lines are going to be parallel. We were given that, but we're showing that by the corresponding angles converse postulate. And now we can see that angle 1 is congruent to angle 4 because this is congruent to this is congruent to this, and this is congruent to this. Therefore, this is congruent to this. That's a transitive property. So angle 1 is congruent to angle 4. And because these are alternate exterior angles, if two lines are cut by a transversal so that the alternate exterior angles are congruent, then the lines must be parallel. So we know that line L is parallel to line N. So that's just a really quick, if you didn't follow that, go over it again, but it's really not necessary. It's a basic transitive property, and you can do this with almost any of these relationships that we go through. Even if they're not explicitly stated, there are many transitivity type problems that we're going to be working through, but we might not state the theorem itself. So if this is parallel to this, and this is parallel to this, then this is parallel to that. All right. Now let's use these converse theorems and postulate to prove whether or not lines are parallel. And so let's look at some examples. In this problem, we're being instructed to find the value of x that makes the lines parallel. What that means is here we have two lines cut by a transversal. In order for these lines to be parallel, we're going to have to use one of the converse theorems. In this case, we have an expression for this exterior angle and this exterior angle. So we're going to be using the alternate exterior angles converse. So this angle and this angle would have to be congruent in order for these lines to be parallel. So in order for this to be congruent to this, this has to be equal to that. So that's what we're going to do, is we're going to set this expression equal to this expression and solve for x. And that value of x will give us the angle measure that makes these two angles congruent. To get started here, let's do 7x minus 15 equals 5x minus 3. Now this is the greater x term, so I'm going to subtract 5x from both sides. And I have 2x minus 15 equals negative 3. Now I'm going to add 15 to both sides. And 15 minus 3 is going to be 12. And that equals 2x. And then I'm going to divide by 2. So x equals 6. Now we're not told to find the value of these angles, but I want to show you something that's really important here. If we were to substitute this number, this x value, in for the x expression here and here, we would get an interesting result. So let's go ahead and do that. This angle is 5 times x, which is 6, minus 3. So that's 30 minus 3, which is 27 degrees. And here we have 7 times 6 minus 15, which is 27 degrees. What do you notice about this? Now, you should see that this angle appears in the picture to be obtuse, yet the answer came out to be acute. So remember what I told you before, never trust the picture. Only trust the information given to you in the picture. Even though this looks like an obtuse angle here, it's actually an acute angle. So don't let the picture fool you. Sometimes the pictures are intentionally designed wrong. They're designed not to scale. They're designed improperly to see if it confuses you. Always rely on the information given to you and what you can prove, what you know about the information given, not what it looks like from the picture. Now, there will be times we're going to be using the expression, if these lines look parallel, they are parallel, but unless you're explicitly told that, never trust the picture. All right, let's move on and do another problem. In this problem, we have two consecutive interior angles. Now, the only way that this line and this line can be parallel is if this and this are supplementary. These two angles must be supplementary angles in order for this line and this line to be parallel. So that gives us our treatment. We're going to say that 5x plus 3x plus 4 has to equal 180 because these two angles must be supplementary. So 5 plus 3 is 8x plus 4 equals 180. Subtract 4 from both sides. 8x equals 176. And we divide by 8, so x equals 22. Now if we plug that in, we have 5 times 22, which is 110. And here we have 3 times 22 plus 4, which is 70. And yes, in fact, these angles are supplementary, so we've got a check on our information. All right. That pretty much wraps up the basics for our postulates and theorems related to parallel lines. And we've looked at, just to recap, we've looked at the consequences of having two parallel lines cut by transversal, and that the alternate interior, alternate exterior, and corresponding angles are congruent, and the consecutive interior angles are supplementary. And then we looked at the converse of those theorems and postulate, that if two lines are cut by transversal so that corresponding alternate interior or alternate exterior angles are congruent, then the lines are parallel. And lastly, if two lines are cut by transversal so that the consecutive interior angles are supplementary, then the lines are parallel. So the first set shows us the consequences of two lines being parallel. The second set tells us how to show that two lines are parallel. Now we're going to move on and we're going to look at perpendicularity in relation to intersecting lines and the different theorems related to that. And we're going to do that starting in the next session. So I will talk to you in the next video.